So up until this point, we've done all of our proofs using theorems, definitions, and we've done just a two-column proof, getting from a given statement, using our geometry facts, and getting to a proof statement. Today what we're going to be doing is using indirect reasoning, okay, which is basically proving something by a contradiction. So proving that something can't happen, therefore the other thing must be true, the opposite of it must be true. So the indirect reasoning example says, suppose your brother tells you that Susan called a few minutes ago. So you think through these steps in your head. First you'll think, well, I have two friends named Susan. So you're kind of figuring out which one called you. You know that one of them is at band practice. So you conclude that the other Susan must have been the caller. So kind of contradiction, Susan was not able to call you, she's at band practice, so we eliminate her, therefore it has to be the other Susan. Okay, kind of the same thing, but it'll be geometry in terms of us proving something. The contradictions will be something we know, like triangle sum. Like maybe it'll contradict, like the angles would no longer add up to 180. Or it could contradict the definition of acute or definition of obtuse triangles. So the definition of indirect reasoning is all possibilities are considered. Just like here, they considered all the people she knew named Susan. And then all but one are proven false. All the possibilities are considered, and then all but one of them is proven false by something we know to be true. If all but one is false, then only one remaining possibility must be true. So you're almost like process of elimination a little bit. Consider all of them, and then you're going to eliminate the choices that couldn't happen. And so then you're left with what has to be true. So an indirect proof uses this reasoning. In this type of proof, a statement and its negation, which remember yesterday has the opposite truth value, are often the only possibilities. Okay, so right below there's a summary chart that tells you exactly how to write an indirect proof. You will see some blank ones on the back of the note sheet and also in your homework. Some of them are fill in the blank. Some of them are just complete an indirect proof. They are not as rigid as a two-column proof where you have to state everything exactly as needed. It's more of a paragraph proof where you're just kind of explaining. But there are 3 steps, and you'll want to have step 1, step 2, and step 3 listed when you're doing an indirect proof. Step 1 is to state as an assumption, the opposite or negation of the prove statement. Okay, so whatever the prove statement is, if you want to prove that quadrilateral PQRS does not have 4 acute angles, you're going to try to prove the opposite, that it can have 4 acute angles. Step 2 is to show that this assumption leads to a contradiction, so that the negation contradicts something, quadrilateral sum, triangle sum, etc. Once you prove that the negation can't happen by this contradiction, then the original statement must be true. So conclude that your assumption must be false and that what you wanted to prove must be true. So you basically restate the proof statement as step 3. Okay, example 1. Write the first step of an indirect proof. So again, the first step is to state an assumption that the opposite or negation of what you want to prove. So the proof statement says quadrilateral PQRS does not have 4 acute angles. Is what you want to prove. So the negation of that is that quadrilateral PQRS, or assume quadrilateral PQRS does have 4 acute angles. It doesn't ask us to do step 2, but let's just think it through. Step 2 is to show that this assumption leads to a contradiction. So why would having 4 acute angles lead to a contradiction of a quadrilateral? What do we know about quadrilaterals? They have 4 sides. What else do we know about their angles? How many degrees total are in a quadrilateral? 360. Okay. So if all 4 angles are acute, that means that each angle is less than 90, right? That's the definition of acute. If we were to add up 3 numbers that are less than 90, what would happen? It wouldn't be 360, okay? So we would say step 2, each angle is less than 90, and this would contradict quadrilateral sum, which is 360. And then step 3 would be to say, this proves the assumption false. We don't have room for this in our paper. We're going to do it on the back. Therefore, quadrilateral PQRS does not have 4 acute angles. And you just kind of restate the proof statement at the end. So all you're doing is you're proving a contradiction, that the opposite can't occur, therefore the original has to be true. Okay? Next one says, prove an integer n is divisible by 5. So the first thing we're going to do is we're going to try to state the negation, see if we can prove that with a contradiction. So this would be, assume an integer n is not divisible by 5. We're not going to do that proof because it's not really provable without knowing what n is, but the other one was something we could do the whole thing. They didn't give us enough given information. We don't have the given for this. So when we get to the back, we'll do a whole one again. And then number 3 says, prove that the measure of angle A is greater than the measure of angle B. What would the negation of that be? Step 1 is to state the negation of the proof statement. What would the negation of this be? What's the opposite of being greater than? Joseph?
Measure of angle A is less than or equal to measure of angle B.
Good. Assume that the measure of angle A is less than or equal to the measure of angle B. The negation, the opposite. And then 4 goes on to the back. It says, prove a triangle cannot contain 2 right angles. So step 1 is to state the negation of the proof statement, which would be a triangle can contain 2 right angles. Let's do step 2 for this. What would this violate or contradict? A triangle had 2 right angles. What would this contradict something that we know about triangles and their angles? What does it mean to be a right angle? Elin? Good. We know that each right angle has 90 degrees. By the definition of a right angle. If we have 2 right angles, that's going to contradict what, right?
Triangle sum.
Triangle sum. If 2 of the angles add to be 180, we don't have a third, therefore it's not a triangle. This would contradict triangle sum. And then step 3, which you may or may not be able to fit, which we're going to do another one below, would be that this proves the negation false. Therefore, the original proof statement has to be true. Therefore, you restate the proof statement, a triangle cannot contain 2 right angles. And again, I'm pretty lenient on how you write it out. I would like to see the word contradiction or contradicts in step 2, because that's the whole point of step 2. But you will be, when I grade it, I'll be reading it through and just making sure it makes sense. It doesn't have to be specifically saying it in a certain way, as long as it gets the point across of what is the contradiction. All right, so we have a couple statements. They just want us to identify the two statements that would contradict one another. So which two cannot happen at the same time? We have triangle ABC is acute, triangle ABC is scalene, and triangle ABC is equiangular. Which two of those contradict one another, meaning they can't happen at the same time? They would contradict one another. Is it acute and scalene, scalene and equiangular, or acute and equiangular? Which two contradict one another? Rep. 2 and 3. Remember that if something is equiangular, it's also equilateral. All congruent sides, all congruent angles. Scalene means that none of the sides are congruent, so those two would contradict one another. How about the next one? Which two statements contradict one another? Could not happen at the same time. FG is parallel to KL, FG is perpendicular to KL, or FG is congruent to KL. KL?
FG is parallel to KL and FG is perpendicular to KL.
Good, 1 and 2. You cannot be parallel, meaning you don't intersect, and be perpendicular, which means you intersect at one right angles at the same time. And then, how about number 7? Today is Friday, it is November, today is Thanksgiving. Justin?
Today is Friday and today is Thanksgiving.
Good. Thanksgiving always occurs on a Thursday, so those would contradict one another. Okay. So just kind of setting you up for what we need to do in step 2 is to prove the contradiction for our proof. All right. So given triangle PQR, and sometimes if there's no triangle drawn, some students like to draw one. You don't have to, but let's see how I drew it on my paper. I put Q down here, just because I already have the words typed out. I don't know, it'll be a little bit easier. They want us to prove the triangle PQR cannot contain two obtuse angles. Okay? So step 1 is to state as an assumption the negation of the prove statement. So we're going to take the prove statement and we're going to assume the negation of the proof statement. You do not negate the given. The given stays as is. The only thing you're negating is what you're trying to prove. So we're going to say, what would the negation of this be? Maddie? Good. Assume triangle PQR can contain two obtuse angles. Okay, now I actually in this proof do take and add in which two angles are going to be obtuse. So I just picked two that were in my triangle. So I said assume angle P and angle Q are obtuse. Again, you don't necessarily have to do it exactly like this. I'm very lenient on how you write your proof as long as it leads to a contradiction that makes sense. But this is one way to do so. What do we know about obtuse angles? Maddie? They're greater than 90. So if we were to add the measure of angle P plus the measure of angle Q together, it would be greater than 180 because each of them is bigger than 90. So I said since both are obtuse, and you can write this differently. You could say measure of angle P is greater than 90 and measure of angle Q is greater than 90, but I added the two. Since they are both obtuse, then the measure of angle P plus measure of angle Q has to be greater than 180. This would contradict what? Two angles being greater than 180 in a triangle. Kaylin? Not the third angle theorem. Triangle sum. We need 3 of the angles to equal exactly 180. 2 of them can't be bigger than 180. So using triangle sum, and again, you don't have to write this all out exactly as I have it here, but using triangle sum, we know that the measure of P plus Q plus R has to equal 180. So these right here are contradictions. This contradicts triangle sum. The assumption is false. And step 3 is always to state that your assumption is false, and then restate your proof statement, which is kind of tedious, but we'll say thus or therefore, restate your proof statement that triangle PQR cannot contain two obtuse angles.
Will you have contradiction statement in step 2?
Yes, you can.
Then will we have to put it in step 3 as well?
No. It's basically one big paragraph. I just try to break it up into steps for you. But you absolutely could state that this is the contradiction here instead of putting it here. But you do want to have the word contradict or contradiction somewhere in your work. And again, I'm super lenient on when I'm writing these, as long as it makes sense. Like, you could even write it out in words instead of using actual geometry notation. Since we know both angles are obtuse, that means that each of them is bigger than 90, therefore this violates triangle sum. So as long as you get your point across, I'm cool with it. All right, last one. Triangle XYZ is isosceles. Okay, so the given, again, do not change this. The given always stays as is. The prove is what we're trying to prove using contradiction. So prove that neither base angle is a right angle. Okay? Step 1 is to state the negation of the prove statement. Now the negation of neither is actually that just one, at least one of them is. If you wanted to put both, you could, but and we're going to find out that both would be anyways because we know in an isosceles triangle. What do we know about an isosceles triangle? Marquise? Two congruent sides, and the isosceles triangle theorem tells us that there are two congruent angles, base angles. Okay. But step 1 is to state our negation. So the negation of neither is that at least one. So assume one base is a right angle. So it says neither base angles can be a right angle. Assume that one base is a right angle. That's the negation. If you want, you can actually do a specific one, like assume angle X is a right angle, or assume angle Y is a right angle. What we just talked about was, due to the isosceles triangle theorem, we know that both base angles have to be congruent. This is actually the isosceles triangle theorem. Let me fix this. Definition of isosceles is two congruent sides. So due to the isosceles triangle theorem, the two base angles must be congruent. Therefore, angle Y must also be a right angle. We know that right angles are 90 degrees. So if both of those are 90 degrees, what does this contradict? Why can't this happen? Good, the triangles add 180. A lot of times the contradiction is triangle sum, because we've done a lot with triangles. So again, Luke, if you want, you could do your contradiction right here. This contradicts triangle sum. I think I have it in step 3 just for the space. This contradicts triangle sum. Therefore, the assumption from step 1 is false. Thus, restate your proof statement that neither base angle can be a right angle. Okay, so there's two fill-in-the-blank proofs so that you kind of just have to figure out what to put in the blank to justify. And then there's one that is completely blank, where you'll want to do step 1, 2, and 3. And again, there's some leniency on how you write it and justify, as long as it does make sense. You definitely want to have step 1. Step 1 has to be there. So you have to have your negation. you have to have a contradiction somewhere in steps 2 or 3, and then step 3 is basically to restate your approved statement. See if you guys can try the closure, just identifying the two statements that contradict one another while I pass out your homework.